sorry, Jackie.
Mommy loves you.
I forgot. Okay. Does that make sense now with this one?
I still don't get it so much.
You still don't get it so much.
I don't really get it.
What don't we understand? Is it
The 7,
the part B?
So pretty much take the total distance traveled and divided by B minus A. But what's B minus A?
Okay. If I was trying to find the average velocity of something, let me write it out to you this way. If I was trying to find average value, I'm having technical. Okay, so average, let's say I said, what's the average velocity? The average velocity would be, it would be 1 over b minus a, integral from a to b of, let me erase this, let me write v of t. V of t dt. Okay, does that make sense with the average velocity? That would be if we actually knew the velocity curve, but we don't know. So we're going to take this integral and we're going to approximate it by using the trapezoidal approximation.
That's the closest we can get without knowing the curve.
Right, we don't know the actual curve, so we're going to use, almost always on the AP exam, they'll ask you to use trapezoidal approximation when you have a table of values. Not always, but it's, yeah.
Will it tell you? Like, will it be like?
It'll tell you. If it doesn't, I'll show you what words to look for in that case. So the average velocity, now what is this b minus a? The b minus a, this would be like your t2 minus your t1. So your start time would be 0, end time would be at 4. So it's 1 over 4 minus 0. And then using part A, we have that approximation. Does that make a little more sense? Or
Oh, so it's 1 over 4 times.
it's 1 over 4 minus 0 times our trapezoidal approximation times t,
Which is just that over.
which is what we had for part A, which is 113 over 4.
Can we also just? If you get the first part wrong, you're pretty much screwed for the second part.
Okay, so if you get the first part wrong but you solve the part B correctly, I only take off for part A.
So if you multiply, basically if you divide a wrong first
Remember, it's
part
just like any other test, and it's similar to free response questions on the AP exam. Like if you get the first part wrong, but you do the second part based on your results, they don't dock you points the second time.
And for the trapezoidal approximation, will it always be uniform, pattern?
Well, you mean
Are you going to be mean and give us
the time intervals may not be consistent. They might.
Is it different? Like, might.
And in that case, we need to know it's the base length times, and then both bases, it's the same thing except you can't do 2 times whatever because I'm not showing you.
Right, you're not going to do the 2 times all the middle ones because they're
Different.
What is
Diff-
that one? How do you do it that way? It's different.
Actually, there's one in the study packet. There's one in the-
yeah. There was one in our notes. Was it notes packet or
Yeah,
homework?
pretty sure it's not packet.
Adam?
Oh, it was homework.
Why is the beginning of this 12 minus h over 12?
Okay, so the height of the cone is 12 feet, right? So what happens? We have the cone that's inside there that kind of gets flipped around is a similar cone. So the base of this R here is to 6 feet as 12 minus h. So like this, because like this whole thing is 12, so from here to here would just be 12 minus.
Wouldn't that just be h?
I guess you could probably, you know what, you could probably solve this in a different way. Hold on, I haven't looked at this problem for a year. So let me see here.
Iceberg slope.
Like Titanic sinking.
It's actually saying pretty fast.
That's why
No, I'm sorry, you're right. This is h. So the radius to this radius, and we have 12 minus h over 12. Why did I not just label that with h?
Who knows?
It's a good question.
So that means you did it wrong.
No.
What's the difference? Yeah, thanks, it's how you know.
But see, the thing is, they're going to change. Are they going to change?
The radiuses can't change.
Did you try? Did anybody try solving it with just h?
Wait, what is he proposing? What is he proposing?
Saying that this. See, I have here for a reason. When I solved it, I have 12 minus h there.
He's saying just do H.
So that would be this distance would be 12 minus h if this is being labeled as h, which I think is how I read it. Let me read one upside down inside the other. The two bases are parallel. The vertex of the smaller cone lies at the center of the larger cone's base. What values of r and h will give the smaller cone the largest possible volume? I wonder if you just had h, if that would work. Oh. I'll come back to this. That's a good question. I'm sure I solved it that way for a particular reason.
Similar to this would be like 12 behind.
What's that?
Is the one on the test gonna like equate it cylinder? Or maybe. And it's bonus on the test.
No, I'm going to make the one on the test a related rates.
Related rates is the one.
The d dt at both sides. And then you plug, like you come up with an equation, then you do d dt at both sides, and then you plug in, like
Oh,
remember, like the one with the police car going one way?
You can't. Oh, I know those ones. And like you have to like it tells you like the volume is increasing at this, but it's high to be.
Right.
But it's good. Oh, no, that's weird.
Okay, so all right, so for homework,
Wait, I have a question. Wait, for the bonus, are we doing that one, or are we gonna do?
we're going to do a related rate.
Sit up for the word.
So don't worry about the optimization one. I'm going to go back and review that one anyway to see why I solved it that way.
Okay.
Yes.
I need-
For these like properties of the definite integrals, are we gonna need to know like the log ones and stuff? No. Is there a calculator?
No, the LN.
She's getting it.
What about the LN one?
So which one?
The LN one. Where it's like LN? It's where it's like 1 over X.
Yes, that one you need to know.
Okay, well.
You need to know the power rule.
Hi, Mr. Chico wanted to know if he left his phone and computer charger in here.
I- He doesn't even teach in this room now. Does
Yeah,
he teach?
he said that if there's any place it would be, it'd be here.
What room number did you
No, I think it's the wrong room.
4.
204 is next room over. Okay.
Should we drink your coffee?
I'll get there. I'll drink my coffee.
How's it going? I need 38B, and then is one like 54 gonna be on the test?
Okay, just a minute.
Because 54 is a
Let's
long
read
way.
homework questions. Homework questions.
33, 38.
I heard, Natalie, you said 20?
33.
No, I said
33,
54.
38B.
And 41.
I need 38B.
38B.
Yeah. Is 54 gonna be on the test? It's the one with the curve and like find all the stuff that one we did yesterday.
Oh, no, but you'll need to know that very soon, so.
So do it. Why'd you assign him as case then?
Oh, okay.
I'll do 38.
You have it? Okay.
No, I don't know. I get. No,
Oh, you want me to explain it?
I'm
Okay.
33. I get. I'm trying to think of why we should put stuff in and stuff. Yeah.
Okay.
Wait, 33
So-
is just so long.
What was the question? Velocity. Yes, possibly. Something similar. Okay, oil consumption. So these are the words that you might see. I mentioned previously on the AP exam, like a multiple choice question where you might have to use left Riemann sum or right hand Riemann sum or midpoint. So when it says upper estimate and a lower estimate,
I
so
was just gonna guess, but then I looked at the solution and it made more sense.
the upper estimate would be your
L, R,
RRAM,
yeah.
and the lower estimate would be
L.
LRAM.
And the trapezoidal's just the.
And then the trapezoidal rule, and notice it's just daily, so it's evenly spaced, so we don't need to worry about that.
So it's just, it's,
So do you need, what's the question here?
what would our,
So notice it's in hours, and this says day, so the hours would be 24, right? What's the time interval? Sunday to Monday would be 24.
24 hours.
24. 24. Are we okay with that?
so that would be a stat over 1/2, 12, or
Yes. Yes.
for our trapezoidal. Or, no, wait a second, which ones are?
No, okay, so for how would you write out the Riemann sum? It would look like what?
I don't know what the equation is.
So, we do,
So you would have what?
we have 1/2.
No. Just for
For our range,
for 33A.
isn't it always one?
What's our RAM would give our upper estimate. So it's going to be base times height plus base times height plus base times height and so on. So since the base for all of these is going to be 24, you could just put in parentheses. So I'm not going to use 0.019. I'm going to use
Left hand.
the second one. And I'm going to use 0.021.
2.35.
Okay, and I'm going to use all of these until we get to the last one, which is,
Did you just write that down? Okay, sure.
no, that's fine. So does that make sense?
Yeah.
And then for the lower estimate, for B, we're going to use LRAM. And we are going to use the first one. Oops, there's a 0 there. But we're not going to use the last one, so it's going to go up to 0.031. And then how does the trapezoidal, sorry, that's not part B, that was still part A. What's the trapezoidal? It's going to be 24 over 2.
Or you can do the
Wait, no,
average.
wait. I thought the trapezoidal is the opposite. So instead of, wouldn't it be 0.01?
Okay, what is my base for LRAM and RRAM? My base is 24.
So isn't that now our height?
That's now our height, so that's why we do H over 2, so 24 over 2.
Oh, okay.
Okay? All right, so we're all right with 38
B.
B.
Because I got the antiderivative I got, but then I didn't understand like how we like, because we only got a to the 3 halves for the answer. But
You only got what?
so like the antiderivative is 2/3 a to the x to the 3 halves.
Okay, so we got, so A is just a coefficient. You got 2
So we
thirds.
have 1 over a, and then the
Antiderivative should be 2 thirds.
a to the x to the 3 halves.
Okay,
Yeah.
so we already
Yeah.
have an A, and then times 2 thirds.
That's 1 over it. What's that?
Well, no, I see that.
Oh, okay.
But, so when I do this,
Yeah.
from 0 to A,
Maybe that's what it is.
the A can go, since A is just a constant, A can go out in front,
Yeah.
and then what?
Then you can cross them out.
So what's the result when I do the antiderivative? So x to the 3 halves over 3 halves, evaluated from 0 to A,
Yeah.
and then what?
Like-
A times 2 thirds, and then it's going to be A to the 3 halves. And then when you plug in 0, that just goes away. So what do we get for the whole thing? a to the 5 halves?
That's not what the answer is, though. That's what it's.
Oh, what's the answer say?
3 halves.
Oh, I can.
That's why I was confused. Because you have an extra full A.
Because you have to do the 1 over the A, 1 over A minus 0.
Oh, I'm
and
sorry,
Oh,
we
yeah.
missed the average
Yeah.
value part.
Yeah. I did
So,
the same thing.
you're right, if we do average value,
Then the A's cancel in front.
it's gonna be 1 over A, so all of this will cancel the A that's out in front. So you're right. Okay, and then we have 41. Okay, so 41. What happens with 41? We
Flip
could,
it, you just plug it in.
so change it to a negative. So when I do the derivative of this, it's just gonna be the opposite of 6 over 3 plus x squared, or sorry, x to the 4th. We're good with that? And then for 54,
That's one of the ones that we don't really need, but like just as
Oh. I have mixed feelings about, 54 is a really good problem,
But we haven't done it
but
yet.
we need to do some more practice with it in the next chapter.
Assign it.
Yeah, let's unassign it.
Why don't you wanna have it assigned?
Because it's like, it's
it's
wasting
I
our
I
free time.
accidentally did 45 instead of 54, so I'm doing 54 right now.
Well, I do,
We don't
see,
wanna
now
do-
I'm tempted, maybe I should just throw a couple problems on the test.
No.
So
Wait,
g
what?
of 1
No,
would be
just-
0, because what happens here? You get the same lower and upper bound,
Wait, can you?
because so g of x is defined by the area under the curve of the function that's provided. So I actually don't even need to look at this graph. Just look at what happens when I plug in, replace x with 1. Do you see that?
Yeah.
So g of 1 is going to be the integral from 1 to 1 of f of t dt, and we learned that if the bounds are the same, then there is no area under the curve. So that's 0.
Oh, we learned that.
Yeah, well, just think about it. If you're looking at the area under the curve over an interval and it doesn't go anywhere, there's not going to be any area under the curve. Next one. So what about g of 3? So g of 3 is going to be the integral from 1 to 3
Oh, it's that.
of f of t dt. So now look back at your graph. So from 1 to 3, it's the area of that triangle, and it's under the curve, so it's going to be negative. So everyone see it's negative 1/2 2 times 1, so it's negative 1. For part C, what's g of negative 1? So it's going to go from 1 to negative 1 of f of t dt. So you have to flip it to make the lower bound smaller. So now if I look from negative 1 to 1, how would we figure that out? It's a quarter of the circle.
You didn't put a negative sign.
Good catch.
Good catch. So it's a quarter of a circle with radius 2. So it's negative 1/2 pi times 2 squared. No, 1/4. Sorry.
Yeah. It's like a quarter, it's not 1/2.
I know. I was going to say it doesn't match the answer. Negative pi. Making all kinds of mistakes here. Good? Then what? D, find all values at which G has a relative maximum. So where does G has maximums? Well, first of all, when G,
Negative 1.
what do we have to look at? G, how do we know if something has a maximum? If the derivative goes from,
Oh, negative positive.
so if we're looking at a maximum, it has to go up and then come back down, right? So when G prime changes from positive to negative. Okay, so what would be the derivative? What would G prime of x be?
Oh, the function f of x.
There you
Which is
go.
the graph.
So G prime of x is going to be, so the derivative of the antiderivative will be f of x, which we have the graph provided. So now you're looking at the original graph. Where does the graph go basically above the x-axis to below the x-axis?
At 1.
At 1. Is there any other?
Negative 3 is. Wouldn't negative
No, it's
No.
with negative to positive.
No.
wait a second. Oh wait, yeah, 3.
3's the minimum.
So
But
at,
it's only asking for max.
There you go.
yeah, just the maximum. So actually, if I had asked where does it have a minimum, it would be at 3.
And
Because
would you
it
say
went
negative
below
3
the
or-
x-axis to
would you say
above.
negative 3 also?
Yeah.
If it had if it has an endpoint there.
It looks like it does, right?
It does.
Yeah, I think we need to know a little more information, but yeah.
Can we do?
Okay, and then what about E? Write an equation to the graph. Okay, so g of negative 1 we found previously. What was g of negative 1? It was from C? Negative pi. So we have a point. Now, what would g prime of negative 1? This will give us our slope. So remember, we just showed that the derivative of g is going to give us f of x.
So it's like
So what's
2.
f of negative 1?
So like 2.
Looks like 2 to me.
Got it.
2.
So here's our slope. So it's y plus pi equals, that's a positive 2. And then x plus 1.
Yeah.
Okay. So we're good on homework.
Wait, aren't there 2 more parts?
Oh, there's 2 more parts?
There's more?
Yeah.
The earlier parts of it?
Oh,
no,
find the,
there's F and G.
oh, that's good.
Oh, there's F and G.
How would you know the point of inflection?
No. Oh,
Okay, so the second derivative.
Which is-
So g double prime would be f prime of x. So we're going to look at the slope. So where the slope?
So it goes is equal to equal.
So what are we looking for on the graph?
Straight
A
line.
change.
No
So we're
change.
looking at the slope where the slope changes from positive to negative.
The top of the circle.
So where slope changes.
So negative 1 and 2.
No, because 2 isn't,
Negative 1 and 2, let's see. No, it doesn't matter. It just, that's,
I just where the slope changes.
so where the slope changes from positive to negative. So at negative 1 we said,
Yeah.
and at 2. That's perfect.
Yay.
And what was the last
Find
question?
the range of G.
Range of G.
Poem on.
fine. So we already
Got
got
him.
a maximum. It's just
We're wrapping
minimum.
it up.
What was the last question? The range?
Yeah.
We already have the maximum, we just need to put it down.
Do we have the maximum? What was the maximum?
Oh, yeah.
Okay, and what about the minimum?
What is it, the range of
Okay, so G of 1 was negative pi.
Yeah. No, G of 1 was 0 and G of negative 1 was negative.
You're right, I'm sorry, negative pi.
Why would we do it in
What's that?
Why would
So the function G.
So it's above the x-axis here, so if we look at like G of negative 3,
Just up there.
you know what I'm saying? Remember, we're looking at the area under the curve. So we found, what did we say the maximum was at 1?
Yeah, it was 0.
So at 1 it's 0. Then it goes below the x-axis here, so it's gonna get
Negative.
smaller. How much smaller?
But that's only a local minimum. I mean, yeah.
Yeah, but at negative pi, it's gonna go negative pi. Let's see.
We have a left-handed absolute minimum. Or not absolute, global minimum. At -3.
Oh wait, I'm sorry. At g of negative 1, it's negative pi. So g of negative 3, I'm sorry, g of negative 3 would be negative 2 pi.
Why is that?
And this is because when we evaluate this, it goes from
Oh,
1
yeah.
Oh yeah.
to x, and so I forgot we had to switch it around because I got mixed up with the above the x-axis, but we count that as negative because the bounds are switched.
But
So
how do we
if
know
you
it's negative
do-
2 pi?
Well, here to here was this was a quarter
Oh.
of the circle,
Okay.
was a,
Yeah.
and then
Oh,
the
okay.
semicircle
Yeah.
That's already
would be a negative 2 pi.
Okay.
So it'd be negative 2 pi to 0.
Okay.
inclusive.
Yeah.
How do we know that 3s are negative 3s are minimum?
Is it stop
we don't.
Isn't the minimum where it goes from negative to positive?
But see, here, it's 0. Then it goes below.
Wait,
So
isn't
at
it negative
3,
two by
we found it was
50?
-1, but then it goes above, so it's gonna go, it's gonna start
Isn't negative 2
adding
y to the
area.
50?
No,
Why not? Why are we stopping at 0? Why are we stopping at G of 1?
no, we're not stuck. G of 1 is the maximum value.
How do we, oh,
And then
yeah.
notice
Oh,
this,
yeah.
this is gonna count as a negative
Yeah.
integral, and this is positive, but it's not enough to cancel out.
Got it.
So it's not gonna go beyond 0. We'll talk more about these. Okay.
Wait, do you still have our assignments? And I wanna.
Yes, I do have the